Hi all, today we can do some problems based on Zener diode. There are various types of diodes like light emitting diode, photodiode, Zener diode, varactor diode, Shockley diode, etc. What is the speciality of a Zener diode? Zener diode is a properly doped PN junction which is having a sharp breakdown voltage. That is, when we study the current voltage characteristics of a Zener diode, during forward biasing, the characteristics looks like that of an ordinary diode. That is, as the forward voltage increases, initially the current increases, and at the particular voltage known as the knee voltage, the current increases rapidly. But during reverse biasing, it is having a sharp breakdown voltage. We are denoting that breakdown voltage as VZ, Zener voltage. And we can see that whatever be the variation in the current, this Zener voltage remains the constant. So because of this special characteristics of the Zener diode in the reverse biased mode, it can be used for several applications. One of the well-known application of Zener diode is it is act as a voltage stabilizer. Because if we apply an unregulated power across a Zener diode, whatever be the variation in the current through it, the Zener voltage remains constant. Here we can see that the current is varying over a wide range, but this Zener voltage is constant throughout this region. So this IZ minimum is the minimum value of the current at which this Zener voltage obtained, and IZ maximum is the maximum value of the current passing through the Zener diode so that it can operate in the reverse biased mode. This is the circuit diagram of Zener diode as a voltage stabilizer. Here we are applying an unregulated power at the input across the Zener diode through a series resistance R. This series resistor helps to limit the current that is flowing through the Zener diode. Remember, the Zener diode is always operating in the breakdown region, that is in the reverse biased mode. For that, the negative of the Zener diode is connecting to the positive terminal of the supply, and positive of the Zener diode is connecting to the negative pole of the supply. Now, the output we are obtaining across a load resistor. So, if we apply an unregulated power at the input, we are obtaining a regulated power at the output. While doing the problems, remember these points. The Zener voltage will be equal to the output voltage because the Zener diode and this load resistors are connected in parallel. So the Zener voltage will be equal to the output voltage. Output voltage is also equal to IL into RL because output we are obtaining across the load resistance RL. So VO is also equal to IL into RL. IL is the load current, that is the current passing through the load resistance. When we apply the unregulated input, some voltage drop occurs across the series resistance R. That voltage drop across this resistance R will be equal to VI minus VZ. That is, voltage across the resistor R is equal to VI minus VZ. Also, the main current I at this point is dividing into two, IZ and IL. IZ is the current passing through the Zener diode and IL is the current passing through the load resistance. So the total current I will be the sum of the Zener current plus load current. If Zener current is maximum, load current will be minimum. If Zener current is minimum, the load current will be maximum. So we can do the first question. For the circuit shown in figure, find the output voltage, voltage drop across series resistance, the current through Zener diode. So see this circuit diagram. Here the input voltage applied is 120 volt. There is a series resistance of 5 kilo ohm and the Zener voltage across this diode is 50 volt. The output we are obtaining across this load resistance, that load resistance value is 10 kilo ohm. The first one we have to find out the output voltage VO. Second part is voltage drop across a series resistance, that is VR. And third part of this question is the current through the Zener diode, that is IZ. So the first part is output voltage. So what will be the output voltage? Output voltage will be same as the Zener voltage. We have seen that the Zener diode and this load resistance are connected in parallel. So this output voltage and this Zener voltage will be equal. So VO is equal to VZ is equal to 50 volt. And the second part is voltage drop across series resistance. So voltage drop across series resistance is this input voltage minus this Zener voltage, that is VI minus VZ, that is VI is 120 volt minus VZ is 50 volt, so that is equal to 70 volt. Third part is current through the Zener diode. The main current I at this point is dividing into Zener current and the load current. So I is equal to IZ plus IL. So what is will be this Zener current? Zener current will be the main current minus the load current. Now how can we find out this main current and load current? This voltage across this resistance is equal to current into resistance, that is IR. So this I is equal to VR by R. So VR is, that is voltage drop across the resistor is 70 volt divided by resistance is 5 kilo ohm. So this will be equal to 70 by 5 is 14. When kilo is coming to the numerator, that will be milliampere. So the main current is 14 milliampere. So we got I. Now we have to find out the IL. What is IL? IL into RL is equal to the output voltage. So this IL will be is equal to VO by RL, or that is equal to output voltage is 50 volt divided by RL is 10 kilo ohm. So that is equal to 5 milliampere. So the Zener current is equal to I minus IL, that is 14 milliampere minus 5 milliampere, that is equal to 9 milliampere. So 9 milliampere is the current passing through this Zener diode. Next question. Find the maximum and minimum Zener diode current for the circuit shown in figure. A circuit diagram is given. In this circuit diagram, we want to find out the minimum and maximum Zener diode current, that is IZ minimum and IZ maximum. The input voltage given is varying from 80 to 120 volt. It is applied across the Zener diode with the Zener voltage 50 volt through a series resistance of 5 kilo ohm. The output is giving across a load resistance, that is 10 kilo ohm. So to find out the Zener current, we know that the main current will be the sum of the Zener current and the load current. So I is equal to IZ plus IL, or we can write it as IZ equal to I minus IL. So to find out the Zener current, first we want to find out the main current I, and also we have to find out the load current IL. So load current IL we can find out from the output voltage, because output voltage VO is equal to VZ is equal to 50 volt, and this VO, that is output voltage, that is equal to ILRL, because output voltage we are getting across the load resistance RL. So ILRL is equal to 50 volt, or IL is equal to 50 volt divided by RL. RL is equal to 10 kilo ohm, that is equal to 5 milliampere. Now to find out the minimum and maximum Zener current, we have to use the input voltage accordingly. The minimum Zener current we are getting when the input voltage is equal to minimum, that is 80 volt, and the maximum Zener current we are obtained when the input voltage is maximum, that is equal to 120 volt. So first we can find out the minimum Zener current. So to find out the minimum Zener current, the input voltage is equal to 80 volt. So what will be the voltage drop across the series resistance? That is equal to VI minus VZ. So 80 minus VZ is 50. So that is equal to 30 volt. And this VR, that is voltage drop across the series resistance, that is equal to IR, or I is equal to 30 volt divided by R, that is 30 divided by 5 kilo ohm, that is equal to 6 milliampere. So the IZ minimum is equal to I minus IL, that is equal to 6 milliampere minus the load current, that is 5 milliampere. It is equal to 1 milliampere. So the minimum Zener current for this given circuit is 1 milliampere. Now to find out the maximum Zener current, the input voltage here will be maximum, that is equal to 120 volt. So what will be the voltage drop across the series resistance? That is equal to 120 volt minus 50 volt, that is equal to 70 volt. So this IR is equal to 70 volt. So this I is equal to 70 divided by resistance, that is 5 kilo ohm, that is equal to 14 milliampere. So the Zener current maximum is equal to I minus IL, that is equal to I is 14 milliampere minus IL is 5 milliampere, that is equal to 9 milliampere. So the maximum Zener current is 9 milliampere and the minimum Zener current is 1 milliampere. See the next question. A 7.2 volt Zener diode is shown in figure and the load current is to vary from 12 to 100 milliampere. Find the value of series resistance R to maintain a voltage of 7.2 volt across the load. The input voltage is constant at 12 volt and the minimum Zener current is 10 milliampere. Here a 7.2 volt Zener diode is shown. So this Zener voltage is equal to 7.2 volt, that is VZ equal to 7.2 volt. The load current is to vary from 12 to 100 milliampere. Load current is the current passing through the load resistance which is varying from 12 to 100 milliampere. Find the value of series resistance R to maintain a voltage of 7.2 volt across the load. So here we want to find out the series resistance R in order to get the output voltage as 7.2 volt. The input voltage is constant and it is given as 12 volt and the minimum Zener current is given as 10 milliampere. So to find out the value of this series resistance, first we have to find out the voltage drop that occur across this resistance. So the voltage drop occur across this resistance is VR is equal to VI minus VZ. The voltage drop occur across the resistance is the input voltage minus Zener voltage. V across this resistance R is VI is 12 volt minus VZ is 7.2 volt, that is 4.8 volt. Now this voltage drop we can write as the product of current and resistance, that is I into R, that is equal to 4.8 volt. So R is equal to 4.8 volt divided by the current. What is this current? The current is I is the main current from this battery. So this I at this point is dividing into IZ and IL. So I is equal to IZ plus IL. Here it is given that the minimum Zener current is 10 milliampere. So if the Zener current is minimum, that means the load current is maximum, that is 10 milliampere. So we have to consider the maximum load current. What is the maximum load current here? milliampere, that is 100 milliampere. So IL maximum is equal to 100 milliampere. So the total current is 110 milliampere. So the resistance is 4.8 volt divided by 110 milliampere, that is equal to 0.0436 kilo ohm, or that is 43.6 ohm. So to maintain a constant voltage of 7.2 volt across the load resistance, we require a series resistance of 43.6 ohm. Next question. A 9 volt regulator supply is required to run a car stereo system from 12 volt battery. A Zener diode with Vz equal to 9 volt and P max, that is maximum power, is equal to 0.25 watt is used as a voltage regulator. Find the value of series resistance R. A 9 volt regulator supply, that is the output voltage is regulated and it is 9 volt. It is required to run a car stereo system from 12 volt battery, that is input voltage is equal to 12 volt. A Zener diode with a Vz equal to 9 volt and maximum power P max is equal to 0.25 watt is used as the voltage regulator. Find the value of this series resistance. That is, in the Zener diode regulator circuit, we want to find out the value of this series resistance. So to find out the value of this series resistance, first we have to find out the voltage drop across the resistor, that is Vi minus Vz. What is this Vi? Vi is 12 minus Vz is 9 volt. So this VR, that is voltage across the resistance, that is IR, is equal to 3 volt. So to find out the value of this resistance R equal to 3 volt divided by the current. The value of the current I is the sum of the Zener current and the load current. In this question, the load current is not mentioned, but it is given that maximum power is equal to 0.25 watt. So the maximum power of this Zener diode means Vi. This V is the Zener voltage Vz and I is the maximum Zener current passing through the Zener diode. So that is equal to 0.25 watt. So this I is at maximum, that is maximum Zener current, is equal to 0.25 watt divided by the Zener voltage, that is equal to 9 volt. So 0.25 is 1 by 4 into here 9. So 1 by 36 ampere. So from the given maximum power rating of the Zener diode, we go to the maximum Zener current. So the main current I is equal to I is at maximum plus IL minimum. Here what will be this minimum load current, that we can consider as 0. So the main current I is equal to I Z maximum, that is equal to 1 by 36 ampere. So the value of this series resistance, that is equal to 3 volt divided by 1 by 36 ampere, that is equal to 108 ohm. So the value of series resistor required is 108 ohm. See the next question. A 10 volt Zener diode is used to regulate the voltage across a variable load resistance. The input voltage varies between 13 volt and 16 volt and the load current varies between 10 milliampere and 85 milliampere. The minimum Zener current is 15 milliampere. Calculate the value of series resistance R. A 10 volt Zener diode. So Vz is equal to 10 volt. It is used to regulate the voltage across a variable load resistance. This load resistance RL is variable. The input voltage varies between 13 volt and 16 volt. That is, this input voltage is also varying that from 13 volt to 16 volt. And the load current IL, that is varies between 10 milliampere to 85 milliampere. The minimum Zener current, that is IZ minimum, is equal to 15 milliampere. Then calculate the value of series resistance. So in this question, we want to find out the value of the series resistance. So for that, we have to find out the voltage drop across that resistance that is equal to input voltage minus this Zener voltage. So here the input voltage is varying between 13 volt to 16 volt. That is minimum input voltage is 13 volt and maximum input voltage is 16 volt. So which voltage we have to consider? Here the minimum Zener current is given. So to obtain the minimum Zener current, the input voltage must be minimum. So here we can consider the minimum input voltage, that is 13 volt minus Zener voltage is 10 volt. So that is equal to 3 volt. Voltage drop across the series resistance is IR. So the value of the resistance is 3 volt divided by current I. Now, what is this current I? At this point, it is dividing into IZ and IL. Here, the minimum Zener current is given. So, here we can mention IZ minimum. If the Zener current is minimum, the load current will be maximum. So, current I is equal to IZ minimum 15 milliampere plus IL maximum. What is the maximum load current? Load current is varying from 10 milliampere to 85 milliampere. So we have to consider the maximum load current 85 milliampere, that is equal to 100 milliampere. So the series resistance R is equal to 3 volt divided by 100 milliampere, that is equal to 0.03 kilo ohm, that is equal to 30 ohm. So what is the value of series resistance required? That is 30 ohm. See the next question. A Zener diode shown in figure has Vz equal to 18 volt. The voltage across the load stays at 18 volt as long as Iz is maintained between 200 milliampere and 2 ampere. Find the value of series resistance R so that EO remains 18 volt while input voltage vary between 22 volt to 28 volt. A Zener diode shown in figure has Vz, that is Zener voltage equal to 18 volt. The voltage across the load stays at 18 volt. The voltage across the load is the output voltage, that is equal to 18 volt. That is here denoting as EO, that is equal to 18 volt. As long as Iz is maintained between 200 milliampere to 2 ampere, that is minimum value of Zener current is 200 milliampere and maximum value is 2 ampere. Find the value of series resistance so that EO remains 18 volt while input voltage is vary between 22 to 28 volt. To find the value of the series resistor, first we can find out the voltage drop across this resistance R, that is Vi minus Vz. Vz is a constant that is equal to 18 volt. Vi is varying between 22 to 28 volt. If you are taking the minimum value of the input voltage 22 volt, then the current across the Zener diode will be minimum. If you are taking 22 volt here, then we have to consider the minimum value of the Zener current. Then it is equal to 4 volt. Then voltage across the series resistor is IR. So the value of resistance R equal to 4 divided by I. And I is the total current, that is equal to Iz plus IL. Here we have considered the minimum value of input voltage. So here the Zener current will be minimum. If the Zener current is minimum, the load current is maximum. To find out this load current, we know that the output voltage is equal to 18 volt. What is this output voltage? That is ILRL is equal to 18 volt. So this load current will be this 18 volt divided by this RL. What is this RL? 18 ohm, that is equal to 1 ampere. So the load current is 1 ampere. So this current I is equal to Iz minimum, that is equal to 200 milliampere plus this IL maximum, that is equal to 1 ampere. If you are writing it in milliampere, that is 1000 milliampere. So what is the total current? That is I is equal to 1200 milliampere. So we can substitute that value of current in the expression for series resistance, that is 4 volt divided by 1200 milliampere. That is equal to 3.33 into 10 raised to minus 3 kilo ohm, and that is equal to 3.33 ohm. So the value of series resistor required is 3.33 ohm. Next question. In the circuit shown in figure, the voltage across the load is to be maintained at 12 volt as load current vary from 0 to 200 milliampere. Design the regulator. Also find the maximum wattage rating of Zener diode. The voltage across the load is to be maintained at 12 volt. The voltage across the load is output voltage which has to maintain at 12 volt. The load current varies from 0 to 200 milliampere. That is IL is from 0 to 200 milliampere. Design the regulator. Design the regulator means we have to find out the value of the Zener voltage and the series resistance R. Also find the maximum wattage rating of the Zener diode. That is, what is the maximum power rating of the Zener diode, that also we have to find out. So here first is Zener voltage. It is clear that Zener voltage will be equal to the output voltage because the Zener diode and load are parallel. So Zener voltage will be same as the output voltage, that is equal to 12 volt. Now how to find out the resistance? For that we have to find out the voltage drop across the resistor, that is equal to VI minus VZ. VI is 16 volt minus VZ is 12, that is equal to 4 volt. So R, that is voltage across the series resistance, is IR. So R is equal to 4 volt divided by I. What is this I? I is the sum of the Zener current and the load current. It is given that load current is varying from 0 to 200 milliampere. So the minimum value is 0 and the maximum value is 200 milliampere. So here we can consider the maximum value of the load current. Then what will be the Zener current? That will be minimum. The maximum value of load current is 200 milliampere and the minimum value of the Zener current will be 0 milliampere. So what will be this current? That is equal to 200 milliampere. So the value of the resistance is 4 volt divided by 200 milliampere, that is equal to 20 ohm. So we got the value of the series resistance. Now we want to find out the maximum power rating of the Zener diode, that is P maximum. So P maximum is equal to VZ into IZ, that is VI. V is the voltage across the Zener diode, IZ is the current across the Zener diode. Then for maximum power rating we have to consider the maximum Zener current. What will be the maximum Zener current? Maximum Zener current we are obtaining when the load current is minimum. What is the load current minimum value? That is 0. So if the load current is 0, what will be this Zener current? That will be 200 milliampere because total current is 200 milliampere. So the maximum value of the Zener current possible is 200 milliampere into Zener voltage is equal to 12 volt. So the maximum power rating is 12 into 200 milliampere, that is equal to 2.4 watt. So 2.4 watt is the maximum power rating of this Zener diode. Next question. A 6 volt Zener diode shown in figure has 0 Zener resistance and an E current of 5 milliampere. Find the minimum value of RL so that the voltage across it does not fall below 6 volt. A 6 volt Zener diode is shown in figure, that is VZ is equal to 6 volt. It has 0 resistance and knee current of 5 milliampere. Zener knee current is equal to 5 milliampere. What is the knee current of a Zener diode? Knee current of a Zener diode means the current at which the voltage remains constant. That is known as the knee current. That is the minimum value of the Zener current, reverse current, at which the voltage starts to be constant is known as the Zener knee current. So that is minimum value of Zener current, that is knee current, is equal to 5 milliampere. Find the minimum value of RL. We want to find out the load resistance so that the voltage across it does not fall below 6 volt. That is, the output voltage must be 6 volt. So that what is the value of this load resistance required. So to find out the load resistance, we know that the output voltage is equal to IL into RL, where IL is the current passing through the load resistance. So VO is equal to IL RL. So the load resistance will be output voltage divided by the current passing through the load IL. What is the output voltage? That is equal to 6 volt divided by IL. So we want to find out the current passing through the load. So here at this point, the main current I is dividing into Zener current and load current. Here we required minimum value of RL. Minimum value of the load resistance is obtained for the maximum value of the load current. So here we are considering the maximum value of load current. So when we consider the maximum value of load current, the Zener current must be minimum. What is this minimum Zener current? That is the Zener knee voltage, that is equal to 5 milliampere. So this maximum value of the load current is equal to I minus IZ minimum. Now what is this I? I is the main current. So to find out this value of I, first we want to find out the voltage drop across this series resistance. What is this voltage drop across the series resistance? That is VI minus VZ. What is the input voltage? 10 volt minus VZ is 6 volt. 10 volt minus 6 volt is 4 volt. So that 4 volt will be IR. So the main current I will be 4 volt divided by R, that is 4 volt divided by R is 50 ohm, that is equal to 80 milliampere. So the total current I is equal to 80 milliampere. Then the maximum value of the load current is 80 milliampere minus minimum value of Zener current, that is 5 milliampere, that is equal to 75 milliampere. So here this load resistance RL, that is minimum value of this load resistance, is equal to 6 volt divided by maximum value of the load current, that is 75 milliampere. That is equal to 0.08 kilo ohm, or it is equal to 80 ohm. So the minimum value of the load resistance to maintain an output voltage of 6 volt is 80 ohm. One last question. A Zener diode in the given figure has a knee current of 5 milliampere and maximum allowed power dissipation of 300 milliwatt. What are the minimum maximum load current that can be drawn safely from the circuit, keeping the output voltage VO at 6 volt? Here the Zener diode is given. It is having a knee current, that is IZK, is equal to 5 milliampere, and maximum allowed power dissipation of the Zener diode is 300 milliwatt. What are the minimum and maximum load current that can be drawn from this circuit, keeping the output voltage as 6 volt? So in this circuit we have to find out the minimum and maximum load current. The main current is dividing into Zener current and the load current. So we have to find out the minimum and maximum load current to maintain the constant output voltage of 6 volt. So to find out the load current, first we want to find out the main current, because this main current is the sum of the Zener current and the load current. So from this we can find out the load current as I minus IZ. To find out the minimum load current, the Zener current will be maximum, and to find out the maximum load current, Zener current will be minimum. Now how can we find out the main current? To find out the main current, we can find out the voltage drop across this resistor. So voltage drop across this resistance is I R, that is equal to VI minus VZ. VI is 9 volt minus VZ, that is Zener voltage, that is same as the output voltage, so that is equal to 6 volt. So 9 volt minus 6 volt is 3 volt, that is equal to I into R. What is this R? R is equal to 50 ohm. So I is equal to 3 volt divided by 50 ohm, that is equal to 60 milliampere. So we go to the main current. Now to find out the minimum value of load current, we require the maximum value of Zener current, and to find out the maximum value of load current, we require the minimum value of Zener current. To find out the minimum value of load current, we require maximum value of Zener current, that we can find out from the maximum power rating, because maximum power rating of this Zener diode will be VZ into IZ maximum. So this IZ maximum is equal to P maximum divided by VZ. P maximum is 300 milliwatt divided by VZ, that is equal to VO is 6 volt, that is equal to 50 milliampere. Now we required minimum value of Zener current. Minimum value of Zener current is same as the Zener knee current, that is equal to 5 milliampere. So what will be the minimum value of load current? Minimum value of load current is equal to I minus IZ maximum, that is equal to 60 milliampere minus IZ maximum is 50 milliampere, that is equal to 10 milliampere. The maximum load current, that is equal to I minus IZ minimum. There I is 60 milliampere minus IZ minimum, that is same as the Zener knee current, that is 5 milliampere. So 60 minus 5 is 55 milliampere. So the minimum and maximum load current that can safely drawn from this given circuit are 10 milliampere and 55 milliampere respectively. So you try more questions. All the best.